given this parent function, f, state what transformations have taken place to create g. Look at the first two. Absolute value, just standard, absolute value, standard. Next one is a square root, but it's not standard. This one's already shifted, and this one is a cubic function that was already flipped upside down and shifted. So these are going to be a little trickier. These are not going to be so bad. So here's where I'm thinking, or what I'm thinking. The very last thing we just talked about is where we looked at this structure and we said, yeah, we're going to need to get this basic structure, and that doesn't look like it. So really, here's the problem. This is out of order. And I really want this to look more like where the absolute value is first. Well, the absolute value has a negative sign in front, and then that plus 5 is last. So now all I really have to do is decide what does all this mean in terms of how this got shifted. So I think we understand basically, let's use a red pen just for emphasis, just to make it look mad. So G is, okay, G is a transformation of this. And how was it transformed? Let's use order of operations. Nothing horizontal, nothing inside the parentheses, and I'd say that in air quotes, it's really the absolute value. So it's not shifted left or right at all, but it is reflected over the x-axis. I need to rephrase this. I'm going to change this from G to F. F is reflected over the x-axis and then shifted up 5 and shifted up 5 to create G. There we go. All right. Next one does not look like the normal way we're used to looking at it. Sorry, hard to say. This in the absolute value is a little more straightforward. We'd be like, oh yeah, that's a horizontal shift to the right, 9. I hear you. Go ahead and start that sentence if you want to. So F is shifted, because that would be the first thing you do with the order of operations. You'll go with the things that are in parentheses in this case, or the grouping symbols. F is shifted 9 units, not negative, so positive, so it would be to the right. And there's more. So what does this divided by 2 do? Well, let's restructure this a little bit. This is like I have a 1 over 2, so that's 1/2. 1/2, and then absolute value of x minus 9. There's that. There's that. Okay, so F is shifted 9 units to the right, and that 1/2, that's a vertical stretch, and again with the air quotes, so it's not exactly a stretch, it's actually a shrink. So it is shrunk vertically to half of its height. So if I had to go over 1 and up 1 to get to a point, I'd actually, for the G function, go over 1 and up 1/2. So let's word this just right. F is shifted 9 units to the right and shrunk vertically, not stretched, by a factor of 1/2. Okay, now we get to a crazy one, and we may want to Desmos this one. If you want to, you may, but I'm actually not. I think we can do this without Desmosing it. So F is, okay, let's work our way out of our parentheses. And again, when I say parentheses, I'm really referring to grouping symbols. So here, under this square root, we have x plus 2. Just a second. There was a noise in the hall. You didn't need to hear their gossip. You'd rather hear math. Okay, I have x plus 2. So technically, from the very beginning, this function is 2 units to the left. Okay, and this is a square root function. So 1, 2, and you can draw this if you want. I'm going to draw it in green. So it's this, and it goes like that. So this is F. There's F in green right there. Well, when I draw G, which will be purple, it would be 2 units up, but no horizontal shift. So it would be 1, 2, a horizontal shift of 0, and it would go like this. Now, I'm not really capturing its scale, this 0.1. I haven't captured that very well, but we can talk about the other things. So here we go. If this one was f and this one is g, then technically I started with a vertex, not a vertex, but a starting point at -2, but this one had a starting point of, well, an x value of 0. So f is shifted 2 units right. What? Yeah, it is. But this doesn't have a -2, but it doesn't have a +2. So we went from what was 2 units to the left to 0 units to the left from the origin. And so I did have to shift to the right too to get there. Okay, let's talk about this 0.1. Obviously I'm going to go up to in a minute. But this 0.1 is 1/10. So this is 1/10, which is clearly not larger than 1. So f is shifted 2 units to the right, shrunk. Just like this was 1/2, this is 1/10. Shrunk vertically, let's make that vertically by a factor of 1/10 or 0.1. And last thing, shifted up 2. Shifted up 2 units. Okay, last one is a cubic function that was 4 units to the left. Now it's 4 units to the right. So if I started 1, 2, 3, 4 to the left and I end 4 to the right, I've started here, I ended here. I really traveled 8 because these are 8 units apart, and I traveled 8 to the right. So here goes. Let's just go ahead and start it. F is shifted 8 units to the right. I have not used the phrase to the yet. So like 9 units right. Now I'm putting to the right. 8 units right. Okay, this negative is present and now it's not. And I know you're like, well, what about the 1/4? We'll get to the 1/4. So it was upside down, you could say, and now it's right side up. And it's scaled differently, but it was upside down, now it's right side up. So we're going to say that it got reflected over the x-axis. Reflected over the x-axis. Okay, we also have a 1/4 that's not negative, which is because this is not negative. That's where that reflection came from, because it was negative, now it's positive. Reflected over the x-axis, shrunk vertically by a factor of 1/4. And last thing, this one had no vertical shift. This one has 44. There's a lot of 4s in here. And shifted up 44 units. There we go.